Hi, my name is Manish Gupta, and in this video, I'm going to talk about LaMP, which is basically a benchmark for measuring personalization capabilities of large language models. Okay, let's get started. So what is the LaMP benchmark? And as I just mentioned, LaMP is a benchmark for measuring personalization performance for large language models. It comprises of 7 different personalization tasks. These 7 tasks span across 3 text classification tasks and 4 text generation tasks. So the text classification tasks include these tasks: citation identification, movie tagging, product rating. And so citation identification is a binary task. Movie tagging is 15 tags. Predict one of the 15 tags. Product rating is an ordinal classification task to predict 1 to 5 star ratings. So in all of these tasks, the idea is that besides an input X to be able to predict Y, the input also comprises of a personalization profile, a user profile in that sense. Okay, so here are some examples. I'll also talk about the text generation task, but let's look at the examples to understand these 3 text classification tasks themselves. Okay, so the first one is personalized citation identification. Here, the input really looks like this. For an author who has written the paper with the title, so there's a paper whose title is provided, which reference is most related. Okay, so just answer with one or two, and there are 2 references which are provided. So the input comprises of 3 things: title, reference 1, and reference 2. And then the idea is to figure out the author will basically, will cite which reference. Okay. So the output expected is either 1 or 2, and then the user profile that is sort of used is basically the title of the papers that the particular author has written and the abstract of those papers. Okay, it's a binary classification task, so 1 or 2, right? Similarly, the next one is personalized movie tagging task. So which tag does this movie relate to among the following tags? And just answer the tag name without any further explanation. Here are the categories and here is the movie. Okay. So the input is movie, the 15 classes, and the expected output is one of those 15 classes. Okay. Now, I mean, so, of course, the movie is comedy here. And then here, as part of personalization, the user profile comprises of the movies that the user has watched and the tags that the user has provided in the past. Okay. The third task is personalized product rating. So, I mean, everyone knows that the product ratings contain a lot of user bias. So, what is the score that the user would provide to this particular review? And here the user profile comprises of the text, the previous reviews that the user has written, along with the scores. Okay. So those are 3 classification tasks. Now, besides these, there are also 4 text generation tasks as part of this benchmark: news headline generation, scholarly title generation, email subject generation, and tweet paraphrasing. So as one can expect in the news headline generation, given a particular article, you want to generate a headline in a personalized manner where, you personalize on the user history of what articles the user has sort of read, and what are the titles and what is the text of the article. Okay. For personalized scholarly title generation, the task is generate a title for this abstract of a paper. So where you have an abstract and you want to get the title, again, this basically comprises of papers that the user has sort of written with the title and the abstract. Okay. Personalized email subject generation. So generate a subject for this email. Again, it comprises of a user history with the title and the email body of those emails by the same user. Okay. And the last one is personalized tweet paraphrasing. So paraphrase the following tweet without any explanation. I mean, the input is the tweet and you want to paraphrase out. And of course, the personalized user history is basically the history of tweets that the user has written so far. Okay. Now, just like other sort of personalization systems, they do 2 different kinds of splits of their data sets: user-based split and time-based splits, which basically means that in the test part, in the user-based split, the test part basically comprises of new users, right? Which have not been observed in the train time at all. So as to measure the generalization of the system onto a completely new set of users, right? In the time-based data split, the idea is that you have repeating users in between train and test, but then you use the old data about that user for train part, and you use the new data or the recent most data about that user in the test part, right? Um, so now to be able to use LLMs to do this personalization kind of task, one simple way is to basically just take the user profile along with the original input prompt that you see here and combine all of that into a single prompt and give it to the large language model. However, what they observed is that this personalization history could be very, very large, and the profile could be very large, and that may not fit in the prompt. And therefore, the kind of architecture that they proposed is to do this. They take a user profile, right, and they take the input. After they take the input, they try to come up with a query such that they can use retrieval augmentation. Okay, so essentially, they use the user profile, they index the user profile into some database and into an index, and then the retrieval model effectively uses this query so as to look up onto this data onto this user profile, gets the most relevant profile pieces, and then basically concatenates it in some ways along with the input prompt so as to and then passes it to a language model to generate a good response. Okay. Now, for retriever part, right, they basically use various kinds of retrievers. They use syntactic match-based retrievers, so BM25 term matching. Now, remember these user profiles, they don't really contain like millions or billions of entries. So you could just basically index it in simple, simple data structures rather than using approximate nearest neighbor search indexes here, right? So basically they use syntactic match using BM25, semantic match using contriver, which is a dense retrieval algorithm. They also do a recency match in the sense that they basically just return the latest user profile piece. Okay? Or the fourth thing that they can do is just return random document from the user profile history. Okay? So that's that. Now, once you get that, how do you use it for retrieval augmented generation? Well, you can do two things: in-prompt augmentation, the standard RAG. So you basically, look at the user history, get the top K retrievals using this particular query. So the retriever gets you top K retrievals. You concatenate with the input xi, and then use the LLM, the large language model, so as to actually generate the response. So your overall input to the large language model is basically a concatenation of your input along with the retrievals. Okay, so that's basically the in-prompt augmentation, the standard RAG method, right? The other method is fusion in decoder, which basically means that you process each of those retrieved pieces independently. So you basically take the original input xi, along with that, you concatenate a jth document. So you can basically retrieve k different documents, and you basically process each of those j documents through the encoder part separately, and then you do the fusion in the decoder. So in the fusion time, at fusion time, you basically concatenate all the embeddings and then from the encoder, and then use them to generate things. Okay, so there are two different methods that they use so as to generate the final outputs. Now, from an LLM perspective, they actually experiment with two different models, or rather, with flan T5 base first, and then with the larger models that I'll talk about on the next slide. Okay, so here are the results across all the 7 different tasks. And these are the metrics, of course. So these are the classification tasks. These are the generation tasks, right? And what do you see in the result? These are non-personalized tasks. These are tasks which are personalized, but with only one retrieval from the user history. And this is a tuned profile kind of results where you essentially tune what should be the K that should be used and which retriever you should use and so on. Okay. So what is observed is that typically, if you compare, non-personalized versus personalized, you would observe that non-personalized is worse than personalized. So clearly, personalization helps across all tasks. If you compare, right, you will observe that personalization improves performance. You would also observe that even random personalization, randomly just choosing one document from the user profile history basically gives you better results compared to non-personalized results. Okay. So by the way, in non-personalized also, you could have a random baseline, basically meaning, you just randomly choose something from the profile, but a random user profile. You don't really care about this user, just select some sort of a document across any of the users, any random user in the training set. Okay. So that's that. So the point is that personalization improves performance. Even random personalization actually improves performance. And by the way, this random personalization is different because this is really choosing a random document from this current user's profile, right? So even with k equal to 1, so if you look at just k equal to 1 result, this is random retriever, BM25 or contriver. It is observed that the dense retrieval based contriver, which does a semantic match, actually gives you the best results in most cases. Okay. Increasing k actually improves performance. So you would observe that in the lower chart, what it shows is accuracy versus increasing k. And you see the results are shown for all the 7 tasks separately. What you observe is that as you increase k, the accuracy sort of improves. This is mean absolute error. So of course, lower is better. So as you increase k, the mean absolute error decreases. So the trend is that typically as you increase k, the performance improves. And then lastly, tuned models basically give you the best results. So these tuned models give you the best results. Now, it's sort of obvious because when you're doing tuning, you of course expect the results to be better. So while tuning, what is tuned? So in Fusion and Decoder, k is kept 16, but in the IPA method, the k is chosen using a validation set, and also the best retriever is chosen using the validation set. So now, so that was basically an experiment with Flan T5 base, which is not very large. As compared to that, of course, you can compare with the very, very large models like Flan T5 XXL, which is like 11 billion parameters, or GPT 3.5 Turbo. Number of parameters are really unknown, but it is a few hundreds of billions for sure, or more than that, right? So what is observed? So, again, the results are shown for all the 7 tasks, and you see results with user-based separation and time-based separation. By the way, on the previous slide, I just showed you results with user-based separation, user-based train test splits. Even these results, the bottom results are also with user-based separation. Of course, there are similar results with time-based separation in the paper, but I just excluded them because the results are pretty similar. Okay. Um, Now, what you observe with the large language models, so of course there are results with non-personalized models and with personalization, right? So these are zero-shot results. So these basically don't involve any retrieval augmented generation or RAG. They basically just try to put in all kinds of user profile information in the prompt as much as possible, right? So what you observe is that in all of these results, you observe that using users profile, some personalization is better than not using personalization. So in both the cases, as you see, these figures are typically better than the left ones, right? So these highlighted ones are better than the left ones. Okay, so that's that. So using users profile improves performance. However, what you also observed is that fine-tuning small language models is better than the zero-shot performance of large language models. So as you observe, right, the best large language model performance, for example, for the first task, binary classification task is 0.699 in the user base split, right? While here with the Flying T5 base, a small language model with fine tuning, you get like 0.754. Okay. So actually you get better results using Flan T5 base compared to using zero shot chat GPT or GPT-5 in that sense. Okay. So in summary, LaMP is a benchmark with 7 different data sets, 3 for classification, 4 for generation, focusing on personalization for small language models and large language models. They basically use 2 different augmentation approaches to augment documents retrieved from the user profile for solving these tasks. The 2 approaches are the popular approaches people typically use in the RAG literature, the standard RAG or in-prompt augmentation as they call it, and fusion and decoder approach. Right? The LLM personalization basically leads to about to 12 plus 12 point improvement in performance in the zero shot setting on average across these 7 different benchmark data sets, while fine-tuning Flan T5 base basically with personalization information sort of leads to plus 23.5% performance improvement across all of these 7 tasks. Okay, so that's it for this video. Hope you liked it. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.